Principle of AC generator. Next, working. Next, construction of AC generator. Working principle. So next, mechanical energy to electrical energy. So next, rectangular coil. Rectangular coil. Change in magnetic flux. Changing magnetic flux. Next, Faraday's law. Faraday's laws. So we have the two laws. First law, second law, and next to Fleming left hand rule. Fleming right hand rule. Right hand rule. Fleming left hand, right hand rule. Principle construction, working principle. It converts mechanical energy to electrical energy. Rectangular coil, change in magnetic flux. Faraday's law, first law, second law, Fleming right hand. This is a key points. Principle, construction, working principle, mechanical energy to electrical energy, rectangular coil, change in magnetic flux, Faraday's first law, second law, Fleming right hand rule. Now, so first principle. So what is a principle? Electromagnetic induction. Electromagnetic induction means electromagnetic. Now I will explain. So first I'm going to explain construction of AC generator. Construction of AC. This is a north pole. This is a south pole. This is a north pole. This is a south pole. This is orthomagnetic. Orthomagnetic provides uniform magnetic field. Now I'm taking the rectangular coil. This is a rectangular copper coil. This is a full slip rings. One end of this is a armature. This is a wire. Number of wires. Combination of the wires. This is a rectangular coil. Is called as armature. Coil means having number of wires is called as armature. One end is connected to slip rings. Another end of the armature is connected to another slip ring. This is a full slip ring. This is a S1. This is a brush B1. So brush is this is a brush. Now I'm connected to ear bulb. Now connecting bulb. This is a brush B1. This is a brush B2. This is a slip ring S2. Slip ring S2. Now you will see this is a point, this is a B point, this is C point, D point. This is a full slip rings. This is a construction of AC generator. Now we will see this is a north pole, and south pole of the orthomagnetic. So what is the use of this orthomagnetic? It provides a strong uniform magnetic field. Strong uniform magnetic. It provides a strong uniform magnetic field. Next, this is A, B, C, D. A is connected to one full slip ring. So D is another end of the armature that is connected to slip ring S2. Slip ring S2. 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 Now you will see the brushes. This is a brush B1. This is a brush B2. That is a brush B2. This is a brush B2. This is a now you see I'm providing the handle as here. This is a handle. This is handle. Suppose it is rotating anti-clockwise direction or it is rotating a clockwise direction. You will see here orthomagnetic. This is a north pole of the orthomagnetic. This is a orthomagnetic. We call this is orthomagnetic. What is the use of orthomagnetic? Orthomagnetic provides uniform magnetic field. It is closed. Now this is a rectangular coil. This rectangular coil having two ends. One end is connected to full slip ring S1, and is connected to slip ring S2. Yes. So this is a full slip rings, and this is a B1. This is a connecting wire. One wire is connected to one end of the bulb. Another end is connected to another. This is another wire. One wire is connected to brushes. Another end is connected to bulb. Okay, circuit is closed. So what is the use of the bulb? What is the use of the brushes? Brush provides the electrical connection between wire. Here as brush, what is the use of brush? Brush provides the electrical connection between slip rings and connecting wire. This is a bulb. We call this is a load. We call this is a load. We call load. This is a connecting wire. Connecting wires. Okay. This is a brush and this is a handle. This is a handle. That is a handle. So what is the use of handle? Means this is a rectangular coil. Suppose for example this is a armature. This is armature or rectangular coil. This is handle. Handle is rotates the armature this direction. The armature is anti-clockwise direction. I don't want to rotate the armature in the anti-clockwise direction. Means I want to rotate in a clockwise direction in armature like this. That is the use of armature. Suppose handle rotate in a clockwise direction means handle is connected to armature. Armature also rotate in a clockwise direction. Armature having two ends also connected to two slip rings. Two slip rings also rotate in a clockwise direction, but brushes are not moving. Handle is rotating in a clockwise direction means along the armature also rotate in a clockwise direction. Both slip rings also rotate in a clockwise direction. In case handle is rotated in a anti-clockwise direction, handle is connected to armature. Armature also rotate in a anti-clockwise direction. Along the slip ring also rotate in a anti-clockwise direction. This is a construction of AC generator. Key points. Construction. I'm explaining first construction. This is a construction of AC generator. Next, working principle. Come to the point. So, what is AC generator? AC generator which converts mechanical energy to electrical energy. That is a AC generator. AC generator means which converts mechanical energy to electrical energy. Like this is a mechanical energy to electrical energy. Next, rectangular coil. You will see A, B, C, D. This is a coil is rectangular shape. This is a rectangular shape. Now We'll see the rectangular shape. Now we'll see the rectangular shape. Okay, that is a rectangular. Next, change in magnetic flux. Change in magnetic flux. Okay, so change in magnetic flux. Rectangular coil. Rectangular coil means rectangular. So I'm taking the long copper wire. Long copper, right? This long copper wire makes two rectangular shape. Long copper wire. Copper wire is a conductor. The copper wire will make in the shape of rectangular shape. Rectangular shape. This is a one wire. Next, another wire also make to rectangular form. That wire keeps on keep on over the wire. Two or more number of wires is called as armature. Armature or rectangular coil. Rectangular coil. Rectangular coil. Next, change in magnetic flux. Change in magnetic flux. Change in magnetic flux means how does magnetic flux change? Change. Okay, you will see the stage number one, stage number two. Stage number one, two. Suppose, for example, you see the stage number one, stage number two, stage number two, stage number three, stage number four, stage number four. I'm talking about change in magnetic flux. Change in magnetic flux. Change in magnetic flux. Stage number one, you will see basic point. What is the basic point? You will see the mark position. Suppose this conductor, this rectangular coil rotate in a anti-clockwise direction, maybe clockwise direction, whatever. Suppose position of the rectangular coil is first. This is a position of the rectangular coil. Suppose position of the rectangular coil is you take the position of the rectangular coil. This is a vertical direction. Vertical direction. Suppose this is a position of the rectangular coil. But magnetic field is start from north to south. Magnetic field lines. This is a direction of magnetic field. This is a direction of magnetic field. This is the direction of magnetic field. This is a B bar. B bar. Now we'll see. This is a book. This book having this is surface, other surface. This book has two surfaces. This is one surface. This is a back surface. Front surface, back surface. Suppose you see it like this. This is a rectangular part. Now this is a marker. Marker takes as a straight line. Straight line drawn to perpendicular to the surface area. This line, this straight line is called as normal line. Normal line or area vector or unit vector. Unit vector. Now you will see this one. This is normally is upward direction. Normally is upward direction. And backward direction also. Backward. This book also backward surface. This surface having, and this is a marker take as a straight line. Straight line drawn to perpendicular to the outward surface. Outward surface. This is this straight line is called as normal line. This unit vector from the area. Having this side is normal, this direction, and this side is normal is outward direction. This direction normal. Direction of normal is this direction, but this side is normal is this direction. Away from the direction. Away from. Now you will see position of the. Suppose I'm taking this is initial position. This is rotating a anti-clockwise direction. This is anti-clockwise direction. Now I'm taking this is a position mark. This is a armature position. Now this is a position. Now we will take this is a position. This is a normal direction. Normal direction. What is the angle between here? This is a bar and B bar. Angle is theta is equal to 90 degrees. That is our first position. First position. This is rotating in an anti-clockwise direction. I mean rotating in an anti-clockwise. It is rotating this direction means this is a normal. I mean A bar. This is a B bar. Angle is what is angle? Theta is equal to 0 degrees. Now it is rotating this direction and angle is theta is equal to 90 degrees. And it is rotating. Theta is equal to 90 degrees. This is our stages. Now again it is rotating this direction and normally is area vector is A bar is this direction and B bar is this direction. Theta is equal to 180 degrees. Theta is equal to 180 degrees. Now you will see This is a position of the armature, position of the armature, position of the armature. First, you will see in this stage, suppose myself takes as a conductor, armature. This is a normal. Magnetic field lines is this direction, north to south. I'm standing here. Magnetic field lines from north to south. Myself is a conductor. I'm a rectangular coil. This is a normal. Normal is this direction. A bar is this direction. B bar is this direction. This is a B bar direction. This is a normal. What is angle between 90 degrees? Here 90 degrees. Next, second stage, armature is this direction. But direction of magnetic field is from north to south. This is a direction of magnetic field. This is a bar. Both are parallel to each other. Angle is theta is equal to 0 degrees. Now armature is rotating this direction, and A bar, B bar, A bar, B bar. This is A bar. Yeah, this is a B bar. A bar is this direction. What is angle between 90 degrees? Next, again armature rotating this direction, and this is north to south. But this is A bar. What is angle between 180 degrees? Again armature is rotating this direction. North to south is B bar. This is a normal 90 degrees. That is a status. What I'm telling here, armature is rotating in a anti-clockwise direction. I'm telling B bar and A bar, B bar and A bar. So where is a bar? Suppose I may you take this is a B bar direction, B bar direction. So direction of magnetic field is from north to south. This is a north to south direction. North to south direction. I'm a rectangular coil. This is a part, B part, C, D. I'm armature. This is a plane surface having a one normal. This is a straight line. Straight line drawn to the straight line is drawn to perpendicular to the surface. This we call normal. This normal is away from the body. This is a bar direction. A bar direction is outwards. Always this is a B bar. B bar is from here to here. This is a normal. What is angle between? B bar is this direction. B bar direction of magnetic field is this direction. This is a what we call A bar. What is angle between two? 90 degrees. Next, armature is turns 90 degrees. Turns 90 degrees. This is a B bar. This is a bar. What is angle between? 0 degrees. Next, armature is rotating this direction, but magnetic field is this direction. But what is an angle between the A bar and B bar? 90 degrees. Next, again armature is rotating this direction, but magnetic field is from left to right. Armature direction of magnetic field is this direction, and B bar is this direction. A bar is this direction. What is the angle between? 180 degrees. 180 degrees. Now I'm going to calculate the flux. So flux, we have to calculate the flux is equal phi is equal to BA. Next formula, phi is equal to BA cos theta. BA cos theta. Now we will say cos 90 0 flux phi is equal to 0 flux. BA cos 90 flux is equal to 0 in this situation. Stage number 1 flux is 0. Stage number 2, so phi, cos 0 is equal to 1. So phi is equal to BA cos 0 degrees. Phi is equal to BA. Maximum flux we are getting. Next, second stage. So phi is equal to BA cos 0, cos 90 flux is 0. Next, cos 180 is equal to -1. Flux is equal to BA minus phi is equal to minus BA. You will see the all situation. So what will happen in this situation? First stage number 1, armature is at this position. Flux is 0. Next, armature is rotating in a 90 degrees. Flux is maximum. Again, armature is rotating 180 degrees. Flux is 0. Again, armature is rotating this direction. Minimum flux. 0 flux, maximum, 0, again minimum flux. The flux is changing like this. That is a change in flux. We are calling first is 0 flux. Stage number 2, maximum flux. Stage number 3, 0 flux. Again, minimum flux we are getting. That we call change in magnetic flux. We are calling change in magnetic flux. Principle is electromagnetic induction. Construction is this one. And AC generator means mechanical energy to electrical energy. And rectangular coil means A, B, C, D. And changing magnetic flux means armature is at this position. Suppose armature is at this position, zero flux. Armature is at this position, maximum flux. Armature is at this position, zero flux. Armature is rotating this direction, minimum flux. Minimum flux. One rotation completed. Armature is rotating in a armature. Armature has completed one rotation. We are getting zero flux, maximum flux, zero flux, maximum flux, zero flux, maximum, zero, maximum. We are getting the flux. We call that is a changing magnetic flux. Changing magnetic flux. Now Faraday's first law, second law. Faraday first law, second law. You will see Faraday first law, second. Faraday first law, second. So what is a Faraday first law? Faraday first law means Faraday first law. Relative motion between relative motion between coil and bar magnet. So next changing flux. Next induced EMF induced current setup. Induced current setup in a coil. Correct. Relative motion between coil and bar magnet, change in flux, induced EMF or induced current set up in a coil. This is a Faraday's first law. Faraday's first law. Now you will see clearly relative motion between coil and bar magnet means any one should be rest, any another one is rest. Suppose horseshoe magnet is rest position, and this is a rectangular coil in a motion, that is a relative motion. Here bar magnet, horseshoe magnet is at rest position, and armature rectangular coil is in the motion, Horseshoe is at rest position, but armature is in the motion. That is meaning relative motion between the coil and bar magnet. Otherwise, this is a rest. Otherwise, this is a motion. Okay, it is okay. Condition is valid. But both are rest position is Faraday's law is not applicable. Both are rest. This is a right position. Rest or motion. We're doing. This is a rest. This is a fixed, not a fixed. This is a fixed. But armature, this is a handle. So we are rotating in a handle. I'm holding the handle. Handle is rotating in a anti-clockwise direction. Means handle is connected to the armature. Armature is rotating in a anti-clockwise direction. Spring is also rotating in anti-clockwise direction. There is a relative motion between the coil and bar magnet. Next, changing flux. Armature, this is a rest, this is a motion. This is a rest means it is fixed. Armature is rotating like this. What will happen? So first position, flux is 0. Second position, flux is maximum. This is horseshoe magnet is fixed, but armature is motion. Armature is rotating in an anti-clockwise direction by with help of the handle. Suppose armature is at this position, zero flux. Armature rotating in this direction. Flux is maximum. In off rotation, flux is 0. Next rotation, armature flux is minimum flux. Again, the armature rotating in this direction, zero flux we are getting. And a changing flux. That is the meaning of changing flux. So finally, what will happen? So induced EMF, induced current set up in a coil. Induced EMF, induced current set up in a coil. How does it is possible? So magnetic flux, changing magnetic flux linked with the coil. How does it will happen? You will see clearly now. Okay, the armature is at this position. At this position, zero flux. Magnetic flux lines are linked with the coil, zero flux. Maximum flux linked with the coil. Minimum flux zero flux linked with the coil. A minimum flux linked with the coil. Zero flux linked with the coil. Flux is a changing flux. Stage number one flux is zero. Stage number two maximum flux. Stage number three flux is zero. Stage number four minimum flux. And the increasing flux linked with the coil, changing increased flux linked with the coil. This is a closed coil. This is a closed coil. You see, this is a closed coil. This is a closed coil. You see the closed coil. This is a closed coil. So what will happen? What will happen? Say, changing flux linked with the closed coil, then induced EMF, induced current, set up in a coil. Set up in a coil. But I don't know what is the direction of induced current in this generator. AC generator. We have to find out direct current by using Fleming right hand rule. So what is the Fleming right hand rule? Fleming right hand rule means that this is a right hand rule, and fourth finger, fifth finger should be four. Remaining three fingers should be keep perpendicular each other. This finger shows that motion of the conductor. This finger shows that direction of magnetic field line. This finger shows the direction of current. Direction of current. You will keep this is a north and south direction. Next, this is a rotating anti-clockwise direction, means the thumb keep this direction. Current induced in this direction. Current induced this direction. Current is flow this direction, and bulb will be blow. Bulb will be blow. This is your. Now you will see that this is stage number one. Direction of current is from A, B, C, D, S2, B2, B1, S1, supply. This is our first rotation. First stage. Next stage number. And next rotation. Next half rotation. Next off rotation. Off rotation means suppose this is a conductor. Next off rotation means this one. This is a 0 degrees. This is a 90 degrees. Armature rotating. Position of the armature is 0 degrees. This is a position of the armature 90 degrees, 180 degrees, 270 degrees, 360 degrees. This is a one rotation of the armature. One rotation of armature. Again, this is a position of the armature, 0 degrees, 90 degrees, 180 degrees, 270 degrees, 360 degrees. This is the position of the armature. I'm filling next off rotation. This is a rotation of the position of the rotation. Off rotation means 180 degrees. This is a 180 rotation. What is the position of what is the direction of current? What is the direction of current? You will see this is a north pole, this is a south pole, this is armature, this is a full slip rings, this is connected to here, brushes P1, here bulb, S1, B1, S2, B2. This is A, B, C, D. This is off rotation. So what will happen in this situation? You will see this is a magnetic flux lines. Magnetic flux lines linked with the current. Next, you will see Fleming left hand rule. I know direction of magnetic field, and this is armature rotating in anti-clockwise direction. Anti-clockwise direction. You see anti-clockwise direction. This rotating in anti-clockwise direction, and the CD move in upward direction. This is the direction of magnetic lines. This are the connection of current in our direction is the direction of current. You will see the bulb will glow. The bulb will glow. You will see a direction of current, and the stage number 2 direction of current is you will see D C D to C and C to B, B to A, and you will see B to S2, S1, B1. You will see direction of current. In first rotation, current is from A, B, C, You will see the supply. Next, off rotation, current is reverse. Current is reverse. This is off rotation. First rotation, first initial position, A, B, C, D. In this situation, current flows from A to B, B to C, C to D. Next, off rotation. Next, off rotation, current is reverse. Current is reverse. A, B, C, D. This is a current is reverse. Current is reverse. In this situation, current is from A to A, B, C, D. Next, off rotation, current flows from B, C, B, A. Every off rotation, current is reverse in a AC generator. AC generator, first rotation, off rotation. Now, we'll see that is a Fleming right hand rule. That is of Faraday's first law. Now you'll see that is a Faraday's second law. Next, Faraday's second law. So Faraday's second law. The Faraday's second law. So what is the Faraday's second law? Second law. Faraday's. So what is the Faraday's second law? EMF is equal to minus N into d phi by dt. Now we'll see. So phi is equal to BA cos theta. The armature is rotating this direction. Because there is a armature rotating this direction means there is angular displacement. Angular velocity is equal to angular displacement by time. Angular velocity is equal to angular displacement by time. Theta is equal to, we are calling this is theta is equal to omega t. Now phi is equal to BA cos theta means omega t. Now EMF is equal to minus N into d phi by dt, and phi means you can write BA cos omega t. You can write. Now EMF is equal to minus N into BA is constant, d by dt cos omega t means sin minus sin omega t. Again derivative applies here means we are getting EMF is equal to minus into minus plus N BA omega sin omega t. This is we call E naught, maximum EMF. We call E naught means maximum. E means EMF. This is a equation of voltage, alternating voltage, induced EMF. This is a induced EMF set up in a coil. I want to induce current means both sides divide the R and R. E is equal to E naught sin omega t by divide the R and R. R means resistance. E by R means according to Ohm's law, that is the current. This is I naught, maximum current, sin omega t. This is AC current. This is because so voltage or EMF. That is EM equation. Fundamental equation. Fundamental equation. This is a Faraday's second law. So Faraday's second law gives magnitude of EMF, magnitude of current. So Faraday's second law gives magnitude of voltage, magnitude of current. This is a fundamental equation of current. Fundamental equation of current. Fundamental equation of current. Okay, we will see next. That is I is equal to I naught sine omega t. Omega t. E is equal to E naught sine omega t. Omega t. Okay. So VRMS is equal to, this is a formula we call, this is a fundamental equation. Fundamental equation. Fundamental equation. Next. So output of the waveforms. Next, I'm going to draw the waveforms. Waveforms. You see carefully. One rotation. One rotation. You can take the position EMF, voltage. So here, this is a position of the armature. A point, B point. This is a rod. This is a rotating this position, this conductor, a point, this is a B point, this is a cross, this is a dot. This is a current is upward direction, current into the page. The A conductor current is outside, B conductor is current is into the page, current is on page. In this here, A position, this is rotating this direction, B position rotating this direction. Now see this position. B position, this is A position. It is up, it is down. This is cross, this is down. Now this position, this is A, this is a rectangular coil P, this is a dot. That is rotation. One rotation, complete rotation. At this position, EMF also, EMF, vertical position EMF. EMF has a 0 EMF. So what is the EMF here? So time t is equal to 0. Time you can take this is a t by 4. T by 4 plus t by 4. You can write to t by 4. T by 2 here. T by 2 here. And t by 4 plus t by 4 plus t by 4. You can write 3t by 4. 3t by 4. This is a t. What? Your motor here t by 4 plus t by 4 plus t by 4 plus t by 4 now first position in this situation, position of the armature at this position, or I is equal to E is equal to E naught sine omega t, sine omega t. E is equal to E naught sine omega means 2 pi by t. Or omega is equal to, you can write pi f. Here omega means 2 pi by t into small t. I'm writing. E is equal to E naught sine 2 pi by t small t. What is a small t value? This is a t by first is a small t is equal to 0. Sine 0. What is the value? Sine 0, 0. EMF is induced EMF is here 0. This is the first one. Next, second position and second position. So what will happen in the second situation? Second stage. E is equal to E naught sine by t by E is equal to sine 90. So value is maximum. Here Emax. We're getting EMF is maximum. EMF. Next, third situation. The situation, number 3. E is equal to E naught sine 2 pi by t. And the small t value is t by 2. T by 2. T cancel to cancel pi. Sin pi is equal to 0. 0. Yes, 0. Next situation number E is equal to E naught sine 2 pi by t small t. Small t means 3t by 4. 3t by 4. 3t cancel each other. 2 ones, 2 cancel. 3 by 2. E is equal to E naught sine 3 pi by 2. 3 pi by 2 means we're getting E is equal to E max. E max for we're getting EMF is maximum. EMF is maximum. Now last position, time period is small t is equal to t. Now you will see E is equal to E naught sine 2 pi by t. Small t means you can take small t is equal to capital T. Capital T. T cancel each other. E is equal to E naught sine 2 pi. 2 pi means your EMF is equal to 0. EMF is equal to 0. Max 0. Getting negative. Okay. So now we'll see 0. This position EMF is 0. At this position negative maximum EMF. At this position 0 EMF. Again we are getting maximum. This is going to, this is a continue, armature is rotating parallelly, we are getting maximum minimum we are getting. This is a AC generator, output of AC generator. AC generator. This is a AC generator. This AC generator is completed. Now you will see this is a AC generator. AC generator. So you will see the first position at this position. This is a situations you are seeing. Now you will see. This is stage number 1, stage number 2, stage number 3. How do we get the stage number 1, stage number 2? You will see that this is a fundamental equation. This is a current equation. This is the induced current. Induced current. This is a induced EMF. Induced EMF. Induced EMF. You can write this is a current equation also. Current also. Here also current. You can write EMF or current also. Current equation. Now we will take the current equation. I is equal to I naught sin omega t. Sin omega t. Sin omega. Now you will take the first situation. Small t is equal to 0. At this place, I is equal to I naught sin omega means 2 pi by t. Small t means this is I'm writing. I is equal to I naught sin 2 pi by t, and small t means 0. Sin 0 value is 0. Current is 0. You can write current also 0 at this point. Next, situation number 2. Situation number 2. T is equal to, small t is equal to t by 4. I is equal to I naught sin 2 pi by t. Small t is right. I naught sin 2 by capital small t means t by 4. T cancel each other. I naught sin 2 ones 2 cancel. Sin 90 value is I naught value. This is I is equal to I naught. Okay? Maximum current you are getting. That is I naught. Maximum current. Now you will see the third position. Position number 3. Small t is equal to t by 2. Now I is equal to I naught sin 2 pi by capital T small t. Now I is equal to I naught sin 2 pi by capital T, and small t means t by 2. 2 cancel, t cancel, sin 5. Sin 5 value is 0. I naught is equal to 0. Now you will get to the max current is 0 at this position. Now at this position, small t is equal to 3t by 4. I is equal to I naught sin 2 pi by t. In the small t means 3t by 4, and 2 ones 2 cancel, t cancel. Now I is equal to minus I naught. At this position, I is equal to minus I naught. Here again I am getting I is equal to 0. This is a current and this is a time. You can take. This is we call this is alternating current. This is alternating current. This is output of AC generator. Okay. Today class is Orma. Thank you very much. Tomorrow I will continue next class. Thank you very much.